Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 24, Piecewise and Step Functions in Context. Classwork, opening exercise. Here are two different parking options in the city. Okay, so we have two parking places, and 1, 2, 3 parking charges $6 for the first hour or part of an hour. So if you're there for a half hour, $6. $5 for the second hour or part of an hour. So if we were there an hour and a half, it'd be 6 plus 5 is 11, because part of an hour is more than 1, and you'd go to the 5. And then 3 hours and more, $4 for each hour or part of an hour beyond that. So the cost of a 2.75 hour stay at 1, 2, 3 parking is 6 plus 5 plus 4 equals $15. The cost of a 2.75 hour stay at Blue Line Parking is 5 times 2.75, because this one here is $5 per hour up to 5 hours, $4 per hour after that. So which garage costs less for a 5.25 hour stay? So 1, 2, 3 parking I will do in red. And so if we figure this out, I'd say 1, 2, 3 parking. Okay, and that is going to be first hour. So it's going to be 5.25 hours. So the first hour is going to be $6 plus second hour is going to be $5 plus the third hour is going to be $4. And every partial hour after that is going to be $4 from there on out. So hour 3, hour 4, and hour 5 would be $4. And then 0.25 would be into your 6th hour. So here's hour 1, 2, 3, and then hour 1, hour 2, hour 3 would look like this. If there were 4 hours, that'd be 2 at $4. If there were 5 hours, there'd be 3 at $4, right? 1 hour, 2 hours, 3, 4, 5. We're at 5.25, so we have to go up to the 4 hours. So this is what our equation would be. So 6 plus 5 is 11, plus 4 times 4 is 16. So doing PEMDAS, remember order of operations, you multiply first, so 16, and then add left to right. So it would be 6 plus 5 plus 15, which is 11 plus 15, which would come out to be $26. Just kidding, 27. 6 plus 5 is 11. 11 plus 16 is 27. So 1, 2, 3 parking for 5.25 hours would cost $27. Now I'll do the Blue Line parking. So Blue Line. So Blue Line parking. First 5 hours, or $5 per hour up to 5 hours. So there's 5 hours. So it'll be $5 times those 5 hours plus 0.25 is into the 6th hour, which is $4 per hour after that. So that'd be plus 4 for the 6th hour. So 5 times 5 is 25. Plus 4 is 29. Oh wait, I'm sorry. $4 per hour. $5 per hour up to 5 hours. $4 per hour after that. But they prorate it by the minute. So if it was, so they gave in the example, 2.7 hours would be $5 times 2.75. So in this case, it'd be $5 per hour up to 5 hours. So 5 times 5 is 25. But then it would only be $4 for that 0.25 hours. So 4 times 0.25 is 1. So 5 times 5 is 25. So that'd be 25 plus 1, or $26. Okay, page 2 brings us to mathematical modeling exercise. Helena works as a summer intern at the Albany International Airport. She is studying the parking rates and various parking options. Her department needs to raise parking revenues by 10% to help address increased operating costs. The parking rates as of 2008 are displayed below. Your class will write piecewise linear functions to model each type of rate and then use those functions to develop a plan to increase parking revenues. Okay. So parking rates effective October 28, 2008. Short-term rates located on first floor of parking garage and front of the terminal. First half hours free, second half hours $2. Each additional half hour after that's $1. Maximum daily rate of $24. All right, that's short term. Long-term parking rates, which are located behind the parking garage. First hours $2. Each additional hour is $1. Maximum daily rate $9. 5 days $36. 7 days $45. Garage parking rates located on floors 2, 3, 4, and 5 of the parking garage. First hour $2, each additional hour $2, maximum daily of 12, 5 consecutive days 50, 7 consecutive days 64. And then there's the economy remote lot E, shuttle to and from terminal. So if you want to save money, you park way away from the terminal, wait for a bus, load all of your luggage into the bus, and it will bring you to the terminal, then you unload all of your luggage. A lot more work, less convenient. First hour, though, is only $1, and then $1 after that. Maximum daily rate's only $5. Number 1 says to write a piecewise linear function using step functions that models your group's assigned parking rate. As in the opening exercise, assume that if the car is there for any part of the next time period, then the period is counted in full, i.e. 3.7 hours is counted as 4 hours, 3.5 days is counted as 4 days, etc. Okay, so let's start with short-term rates. Let's see, what color can we use? How about red? Short-term rates in red. So let's call that S of X for short-term. Okay, so it's going to be piecewise. We have different things going on here. What do we have? We have someone who could stay for half-hour increments. So the first half hour is free. So there's one time frame. There's a second half hour, $2, and then each additional half hour after that is a third with a maximum of 24. So we're going to have 3 equations, if you will. So how much does it cost for the first half hour? Nothing. So this will be in dollars. So 0 when X, being the number of hours, is going to be greater than or equal to 0, but less than or equal to first half hours free. Less than or equal to 0.5 hours. Okay, so $0 if our time is between 0 and a half an hour. If our time is between second half hour is $2, and then each additional half hour is $1. Okay, so we could do this as a piecewise step function, and that looks like a bracket. And it is $2 per half hour. So 2x. Each additional half hour is $1. So if we take the absolute, or not the absolute, but the greatest integer, if you will, we're going to start with the second half hour, 0.5. Less than or equal to x, less than or equal to, and second half hour is $2. So think about this. If we were there for an hour, the first half hour is free, second half hour is $2. So that's a full hour for $1, is it not? And then each additional half hour is $1. So we could take, so in other words, second half hour is $2, first half hour is free. That would be 1/2 hour that would cost $1. And then the additional half hour would be another $1. So that's why we have 2 times number of hours, because all this adds up to $2 an hour if you stayed for a full hour. It'd be free the first half hour, $2 the second half hour, that's $1. If you stayed for 2 hours, it'd be first half hour free, second half hour $2, third half hour $1, fourth half hour $1. So there's 2 hours costing $4. 2, 3, 4. Okay, so 2 times 2 hours would be $4. If you stayed 2 more half hours, that'd be 1, 2, 3, 4, 5, 6 half hours, or 3 hours. So that'd be 2, 3, 4, 5, $6. So that's where that 2 times the number of hours comes in. And it's the greatest integer because we don't round. So if we're there for 2 hours, it's $4. If we're there for 2 hours and 10 minutes, it jumps up to $5 because each additional portion goes on to the next hour. So this is all the way up to maximum daily rate of 24. So all the way up to 24 hours, 2 times 12 is 24. So that'd be all the way up to the 12th hour. So, or 12th hour. So 12 times 2 is 24. It can't get any more expensive than that. So after 12 hours, basically the next 12 hours are free. And then we could say, well, okay, if we're going to stay longer than that, then we're going to charge $24 when our time is between 12 hours and 24 hours. It would cost $24. Okay. Long-term parking now, I'll put over here, call it L of X equals. So the first half hour is $2. So if I did a scenario here, first half hour, $2. Each additional hour, first hour is $2. Each additional hour is $1. So that'd be 2 hours, 3 hours, 4 hours, writing 4 when I say it, 4 hours, 5 hours, 6 hours, 7 hours, 8 hours, 2, 3, 4, 5, 6, 7, 8, 9. $9 right there after 8 hours. Maximum daily rate is $9, which takes 8 hours for this each hourly rate. So anything over 8 hours or less than 24 hours will cost $9. So we have to figure out how we're going to do that. So it's going to be a step function again, okay? So what is it going to be? It's going to be 2 times the greatest integer x, okay? So if that was an hour, that'd be $2. If it was 2 hours, it'd be 4. All the way up until 6 hours, is it? 1, 2, 3, 4, 5, 6 would be right here. 2, 3, 4, 5, 6, $7. No, that's not right. Okay, so it changes after the first hour. Your first hour is $2. So if we're going to park in the parking garage, it is going to cost us $2 if our time is between 0 and 1 hour. But then each additional hour is $1, but when we get to the 8th hour, we're at our maximum $9. So this would be greatest integer x, because we're rounding the hours up, plus 1 if we're between 1 hour, but it's not equal to 1, because if it's only 1, we're going to the above graph, so we don't want an equal sign there. So 1 is less than x, or x is greater than 1, which is less than or equal to 8. So let's take this into consideration now. If it is greater than 1, in other words 2 hours, it'd be right here. So that would be x, which is 2 hours, plus the 1, which is 3. If it was 5 hours, that'd be x, which is 5, plus 1. So 2, 3, 4, 5, 6. 5 plus 1 is 6. So we're just adding 1 to get this $2 at the first half hour, or the first hour. Okay, so that's where that comes from. So there's our equation, greatest integer or step function x, and then plus 1 added to that. Okay, so then it gets a little tricky. Then we're going to take fractions of these 24-hour periods, which is $9. And now the easiest part here is figuring out your times. So anything greater than 8 hours, but less than or equal to 5 days, 24 times 5 is 120. But minus that 9. Let's think about this. Okay, so now we're looking at the 5 days. Maximum daily rate is $9. So the first day you're going to be charged $9. Maximum 5 days is $36. Well, if we've already calculated the first day, which is 24 hours, this is going to figure the next 4 days. So 24 hours times 4 is 96. So that's going to take up the next 4 days for this 5-day period. So if you're there for 5 days, you're going to use this for the first day and then this down here for the next 4. Okay, so what is that rate going to be? So it's going to be $9 a day times whatever amount of those 24-hour periods there are. So in other words, if it was in the parking lot for 30 hours, let's just say, then 30 divided by 24, 24 goes into 30 once with a remainder of 6, and 1 times 9 is 9, 9 plus 6 is 15. Okay. Now we want to go on, and if we are there for 36, it's going to be $36. So if we only stay there up to 4 days, that's what this is, by the way. So it's going to be $9 times however many 24-hour periods there are. Then on the 5th day, if we stay 5 days, it's going to be $36. So 36 is going to be whenever we're between 96 hours, which is 4 days, and 5 days, which is 120 hours. It's $36. And then finally 7 days would be $45 for any amount over 120 hours, but less than or equal to 7 days, which is 24 hours times 7, which is 168 hours. Okay, so then let me just do this here and fix this. So this had a 2 here, and then our bracket would cover all of these functions. Okay, so for up to 2 hours, or $2 but for the first hour, between 0 and 1 hours would be $2. And I guess you wouldn't have an equal sign here. Do not have an equal sign there. So let me get that out of there. Move this up so I can erase it. Why wouldn't you have an equal sign? Well, if it's equal to 0 hours, it's not going to cost you anything. So it wouldn't cost you $2 if you didn't park there, is what that says. All right, so let's just erase all this side stuff. Dog's choking. Sorry about that. Okay, next one. Let's call it g of x. Let's use blue. G of x, garage parking. Okay, g of x equals. So we're going to have multiple equations, piecewise functions. So what's going on here? The first hour, it's $2. So $2 if time is greater than 0, but less than or equal to 1. First hour, $2. Each additional hour, $2. So that's going to be the greatest integer, x, plus 1, just like over here. And that's going to be up to $12. Well, if the first hour and each additional hour is 2 hours, 2 hours, $2, $2, $2 per hour, it's going to take 6 hours to get to your maximum. Okay? So let's not go there. No, that's not right. That didn't work. I just did the calculation in my head. That's not working. First hour, $2. Each additional hour, $2. I don't need this equation. I could use it and then do a separate one, but if they're all for $2, we can combine them all into one. So if you want to leave that, leave it, but we'd have to also have another one. So then we're going to take 2 times each portion of an hour, because it'll round up to 6 hours, because 6 times 2 is 12, and 12 is the maximum daily rate. So if our time is between 0 and 6 hours, it's going to be 2 times however many parts of hours. So if we were there 2.5 hours, you'd round up to 3. 3 times 2 is $6. Okay, and then we go on to the maximum daily rate, which looks like this. Maximum daily rate is $12. There's 24 hours in a day. So this one was $9. This one is 12. So it's $12 times each portion of 24-hour period is going to be between 6, not equal to 6 though, because that's up here, and 96. Why 96? Because 5 consecutive days. So we're talking about up to 5 days, which is 24 times 5, which is 120, which was like this. And 24 times 4 is 96. So the first 4 days, it's going to be $12 daily. And then on the 5th day, it's going to be $50 for 5 consecutive days, which is $10 a day. So the price starts coming down. Okay, so we're going to take 12 times the number of hours in a day, x over 24, for any time frame between 6 and 96 hours. And then $50 is going to be the amount we're going to use for the time period from 96 hours to the next day, which is 5 hours, 120. It's going to cost $50 for 5 days. And then 7 days is going to cost 64. So we put a 64 here. 7 days is 24 times 7 is 168 hours. So this is going to be from 120 hours to, and including, including up to 120, 168. Okay. And then finally, economy remote lot E. So let's call that economy of x, E of x equals. So first hour is $1, hourly rate $1, maximum daily rate $5. So we're going to have, this one's easier. This one we're going to have a step function. If you're in there 1 hour, it's going to cost you $1. If you're in there 30 minutes, it's going to cost you $1 because it rounds up to 1. You're in there for 2.5 hours, it's going to cost you $3 because this tells us to round to 3. And that happens until we get to $5 or 5 hours. maximum daily rate is $5. So anything between 0 and 5 hours is going to cost us 0 and 5 hours is going to cost us $0 to $5. Then the maximum daily rate is $5, but we could stay there more days. So we take the number of days times the number of hours in each day, X number of hours out of 24. The 5 is the dollar amount. So $5 times however many 24-hour periods there are for any value of where X is greater than 5. Okay. Little confusing. You have to take some time to think about it. Dollar value times portions of days and so on. But that is our set of piecewise functions. Okay, on page 3, they give us a table of parking tickets total in all 4 parking garages. So it says here, Helena collected all the parking tickets from one day during the summer to help her analyze ways to increase parking revenues, and using that data to create the table shown below. The table displays the number of tickets turned in for each time and cost category at the 4 different parking lots. So parking tickets collected on a summer day at the Albany International Airport, short-term parking, long-term parking, parking garage, economy, remote. So they give us an example here. So there were time on ticket hours 1/2, parking cost is 0, number of tickets 400. So there were 400 people who were there and gone within a half hour and didn't pay anything. So parking costs were 0 times 400, or simply 0. And then 1 hour, there were 2 tickets that were marked as 1 hour, and actually it was $2 if you parked for an hour, and there were 600 people who stayed for an hour. So you take 600 times $2, 600 tickets times $2 is $1,200. So there's the example there. So what we need to do is multiply the number of tickets by the cost and add them all up. So I got my calculator here. So I would take parentheses 2 times 600. Yes, you could have just put in 1,200. So 2 times 600 plus 80 times 3. So I'm just going to multiply the number of, or the cost times the number of tickets. So now 3 times 80. So 3 times 80 plus, and make sure you put all your multiplication in parentheses, 4 times 64, parentheses, plus, open parentheses, 5 times 8, plus, open parentheses. So $6, there were 24 tickets, so 6 times 24, $6 times 24, plus 7 times 4, and then no one stayed for 4 hours, no one stayed for 4.5 or 5 or 5.5 or 6, but then someone stayed for 8. So there were 4 tickets that were charged $16. So 16 times 4. And then 18 times 8. And then finally 24 times 8. Okay, so we hit enter and we get $2,308. So I will just write S of X equals, or short term, total revenue for short term. So I don't want to call that S of X. What could we call that? Let's just say short term total. And it was $2,308. Okay, now we're going to move on to the next one, long term, and we'll do 2 times 8 plus 3 times 20 plus 4 times 24, and so on and so on. Tedious, but need to do it. All right, so 2 times 8 plus 3 times 20 plus 4 times 24 plus 5, 6, 7, none, then 8 times 60. 60 cars stayed for 8 hours. 9 times 92 plus 9 times 260. That'd be 8 to 24 hours. 9 times 260. So she's used the piecewise functions to calculate all these separate values. And then 18 for 2 days. 18 times 164. There were 18 cars in the parking lot for 2 days. There were 27 in the parking lot for 3 days at $12, or 12, no, there was $27 to park for 3 days, and 12 cars parked there for $27. So it's 27 times 12. Plus, don't forget your parentheses, 36 times 8. All right, 36 times 20. Plus 36 times 36. All right, I'm gonna mess with you there. 36 times 36 is 36 squared. And then 45 times 32. I forgot my parentheses back here. If you ever do that, you can just hit second and see INS in blue. That means insert, and you can insert a value there. Okay, so we're done, and you press enter. And I got 10,804. Let me see if I got my values right. Let's scroll back. Let's hit enter again. Oops. Guess I can't go back and look. Yes, I can. I just arrow up. So 2 times 8, 3 times 20. No, I can't. Okay. I might have made a mistake there. The key says 10,840. I got 10,804. Either I transposed something or they did. Anyway, I'll put long term total and $10,804. Okay, now we're going to do parking garage. So clear, 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 clear. No, don't want to clear. Let's close that. Okay, so I cleared it, and now we're going to do parking garage. So, time on ticket hours 1, parking costs $2, number of cars that stayed for 1 hour is 8, so it's going to be 2 times 8. Plus 4 times 12. Plus 6 times 8. Plus 8 times 4. Plus, let's see, 10 times 0. Well, that's 0. No need to enter that. 12 times 16. Plus 24 times 96. Plus 36 times 40. Forgot my parentheses, so I just have to arrow back here, second, insert parentheses, and go to the end. Plus parentheses. All right, where were we? 36 times 40, 48 times 12. Plus 50 times 8. $64 times 4. Enter. I got $5,312. Let's see. Okay, I need to check this again. Always good to double check. 64 times 4 matches. 50 times 8 is good. Then it should be 48 times 12. There it is. 36 times 40. That's good. 24 times 96. Yes. And there's, I just found my error right here. I have 12 times 16. It is 12 times 156 I missed. So I skipped one. I did 12 times 16. I did 8 times 4. So I need another one at the end of 12 times 156. I forgot one of my values. You might have seen that when I was typing it. Hopefully you did yours. So it's 12 times 156 added to the end of that. And that gives me $7,184. Okay, so that is parking garage. Total. And it's $7,184. All right, and then the last one, economy remote. So I don't need to add any of these because there's number of tickets is blank. And then we're getting to 5 to 24 hours. So no one stayed less than 5 hours in the remote parking lot. So we start fresh, and it's going to be 5 times 84. 10 times 112. 15 times 64. 20 times 60. 25 times 72. 30 times 24. 35 times 76. 40 times 28. 45 times 8. 50 times 4. 70 times 8. 90 times 4. And 105 times 4. Enter, and I get $11,900. So that is economy remote. Total. Economy total. And it was $11,900. So then we're going to take all of those values, total them, and we're going to get a grand total. So if we take 2, 3, clear, take 2,308, 2,308 plus 10,800. Now the book said 840, so I'll go with that. 10,840 plus, I might have missed a value, 7,184 plus 11,900. Then I get a grand total of $32,232. So a total of $32,232. Okay. That's one day. Alrighty. Okay, page 4 brings us to problem number 3. And it says, the Albany International Airport wants to increase the average daily parking revenue by 10%. Make a recommendation to management of one or more parking rates to change to increase daily parking revenue by 10%. Then use the data Helena collected to show that revenue would increase by 10% if they implement the recommended change. So if I had $32,232 and I wanted to increase that by 10%, then I'd multiply it by 110%, or 1.1. And that would give me 35,000. So our goal is to make $35,455.20, because that's 10% more than the 2,232. So for starters, we needed to know what our goal is. So we need to make, so we made 32,232 on that one day, and so that's a difference of $3,223.20. I also could have taken 32232 times 0.1, and that would have given me this value. So this is what we need to increase by. So if I go back and I look at my table, there's infinitely many solutions to this. We could change long-term parking rates, we could change short-term parking rates, we could change economy rates, we could change all of the rates by 10%, but who wants to pay $1.10 and then you're dealing with change? So there are infinitely many solutions to this. One possibility would be to raise economy to $6 per day instead of $5. What would that do? So economy, $6 from $5. So in order to do that, we would have, that's increasing by $1. We would need 3,223 people to park in economy to make that $6 per day. And then raising something else. So there's multiple different ways to do this. I will leave this part up to you since there are so many rates. What you have to do is go back here and look at the data and maybe use your equations here to come up with a way to make $3,223.20 more than what was made using these formulas. Okay. Okay, page 5 brings us to the end of lesson 24. Go to your problem set.